All right. So before we do division, we're going to do sort of a brief detour and talk about exponents and radicals. Radicals meaning square roots. We can sort of apply either of these operations to fractions. They're kind of extensions of multiplication to a certain extent. The sort of general idea, right? So for exponents, our sort of form is going to be any sort of fraction raised to an exponent. An exponent, right, in general means that you're doing repeated multiplication. So something like 3 cubed, 3 raised to the 3 is 3 times 3 times 3, right? 5 squared is 5 times 5. So what's going to happen for us here is, in theory, this is going to be sort of a over b times a over b times a over b, yada, yada, yada. If we then kind of remultiply, what's going to happen is you're just going to get a times a times a times a on top, which is just going to be a to the n, and then sort of b times b times b on the bottom, which is just going to be b raised to that power. So, essentially the idea here is, the long and short of it is that exponents over a fraction will essentially just distribute to the numerator and the denominator. And so if I have something like, right, let's say 5/6, and I square it, all that's going to happen to us here is this is going to be the same thing as 5 raised to the 2 over 6 raised to the 2. And then, of course, right, if we're talking about numbers here, we can actually evaluate it. 5 squared is 25, 6 squared is 36. If you have, right, something like 2/3, right, sort of raised to the 4, the higher the power, all of this stuff still works. So then this is 2 raised to the 4 over 3 raised to the 4. That's going to be a little bigger. What the heck is 2 raised to the 4? 2 times 2. I'll sort of expand it out, just so we can sort of briefly kind of see this in action, right? 2 times 2 is going to be 4. 2 and 2 is 4, so this is 4 times 4 is 16 up top. 3 times 3 on the bottom, right, is 9. 3 times 3 here is also going to be 9. So that's going to be 16 over 81. You might ask yourself, should I look to reduce these to lowest terms? Do I need to do anything to try to cancel numbers out and kind of shrink them down? And the answer is no. Assuming that your original fraction is in lowest terms, when you raise it to a power, you're just getting more of those same numbers. So if, right, 5 over 6 doesn't reduce, then more 5s are not going to cancel more 6s, right? They're not all of a sudden going to start canceling if there's more of them, if they don't cancel initially. For roots, we'll just do square roots, but I mean, in theory, this applies to any type of root. We have a similar kind of thing. So if I take a root of a fraction, what's going to happen here is essentially the square root will distribute. So I have the root of a over the root of b, right? So I can just sort of take the root over the root. This allows me to take, so for example, something like, right, the root of, the fraction 25 over 16. You might kind of say to yourself, what the heck do I have to multiply by itself to hit 25 over 16? It seems like it wouldn't necessarily be super obvious. And so this allows us to sort of simplify these guys much faster. Of course, in some sense, provided we have numbers that are possible, sort of easy to square root. If the numbers don't reduce with a square root, then you just have the root of the number, and it just sort of is what it is. But in this case, right, so the root of 25 for us would be 5, the root of 16 would be 4. So the sort of answer here would be 5/4. You could kind of double check this. If you did 5/4 and you squared it, 5 squared over 4 squared is going to get us back to 25 over 16. And we'd be sort of back to where we started. So you can kind of use these two rules back and forth if you want to. These things won't show up tons and tons and tons But the sort of, in this section, we have to kind of squeeze these in somewhere. So take a note of it. This happens, and it's here.